This is a question from 3.2 about blood types. And it's talking about the probability that a person in the United States has type AB positive blood is 3%. 5 unrelated people in the United States were selected at random. So here's the first one. Find the probability that all 5 are type AB positive blood. So what you're going to do is, you know that one of them is 3%, which is 0.03, and they're going to be 5 people. 1, 2, 3, 4, 5, and you just multiply all 5 of them. Second question, find the probability that none of the 5 has blood type AB positive blood. Well, your probability is always equal to 1 whole, so 1 minus 0.03 is 0.97. So there are 5 people again, and I'm going to multiply those 5 numbers, and I'm going to get 0.859. The third question says, find the probability that at least one of the 5 has type AB positive blood. And remember from the last example, you always say 1 minus the probability that none of it is going to happen. So if this is the probability that none of the 5 have type AB blood, then I'm going to say 1 minus 0.859, and I'm going to get 0.141 as my probability. Now I put another question on here. It's about warehouses. And it says a distribution center receives shipments of a product from 3 different factories in the following quantities: 50, 35, and 25. 3 times a product is selected at random, each time without replacement. And without replacement means that's when you're going to drop the numbers down because you've already used one of them. Find the probability that all 3 products came from the 3rd factory. Well, the 3rd factory is 25, so that's the one we're going to look at. Well, the first thing you're going to do is add 50 plus 35 plus 25, and that gives me a total of 110 shipments that I'm looking at. And 25 came from this factory, so 25 out of 110. Now, since it's not being replaced, it drops down to 24 over 109. This should actually be 109. Let me switch that. Okay, and then you're going to have 23 over 108. So because it says without replacement, I drop the numbers down each time. And when you multiply all of those, that's going to give you 0.011. And that's the warehouse problem.